Hi, I'm Chris Scott. Over at Solar Stormwatch, we've been using data from the NASA stereo missions to study the sun and the solar wind. The instrument we've been using mostly is the heliospheric imager. That's the big box you can see strapped to the side of the spacecraft. It's about 70 centimetres long and it contains two cameras that enable us to see all the space between the sun and the Earth. The cameras are called HI1, HI2. HI1 has a 20-degree field of view and is between 4 degrees and 24 degrees off the sun, and HI2 has a 70-degree field of view which takes the combined field of view right out to where the Earth is. And these are raw images from both those cameras, HI2 on the left, HI1 on the right. And you can see that most of the signal is dominated by dust, so we can't see anything at the moment. Also, these cameras are black and white, but we can take false colours and we can apply those to the images, and that makes it seem more like we would be expecting. This is an HI1 image, and we've used HI1 images throughout. And you can see that the two bright objects here, Venus and Mercury, are so bright that their signal has bled into the pixels above and below them. But also, the camera has no shutter, so each pixel has been exposed at different times because it takes time to read each pixel out. We can correct for that, but the pixels are still bleeding above and below the two planets. So the way we can correct for that is that we can average the pixels either side of those. And once we've done that, we have a picture which is starting to look slightly more like we would expect. We have this big dust cloud around the sun, but now we have point sources for the planets. But how do we correct for the dust? Well, the way we do that is we take a sequence of images and we look for the least bright pixel in each of those sequence stacks. And that means it must be coming just from the dust because there's no extra signal from stars or planets or the solar wind. Now those move through the image so they don't stay the same, whereas the dust does. Once we've done that, we can subtract the dust away and we're left with everything that moves through the images. And this is what we get. The planets now, Venus and Mercury, the stars in the background, and a massive solar storm erupting from the sun. And once we've done that to one image, we can do it to many images and create a movie. So in these movies, we can see the stars moving in the background as a result of the spacecraft moving. We can see the planets, and it also explains why occasionally the planets look like they're hanging from strings. It's because that excess signal hasn't been taken away. But most importantly, we can see the solar wind and these massive storms erupting off the surface of the sun. Now, computers aren't very good at seeing the edge of these fluffy explosions, but the human eye is, and we'd really appreciate your help over at Solar Stormwatch in tracking these as they go through space so that we have a better understanding of these storms, and it'll help us improve our space weather forecasting.